Hi students, now we are going to derive an expression for the kinetic energy of the body. So kinetic energy is one of the types of which energy? Mechanical energy. So kinetic energy is defined as the energy possessed by a body due to its state of motion. So all moving bodies will certainly possess kinetic energy. Okay students? Now we want to derive an expression for the kinetic energy. For that, I have taken the example of a body of mass m which is placed at a point A at rest. So, what is the initial position of the body is A, and what is the initial velocity of the body at A? It is equal to 0. Why? Because the body is at rest. So, at this point, it is u equal to 0. Now, I am going to apply a force on this body F. So F is the force acting on the body in the forward direction, so that the body is going to move from A, okay, to a new position B, so that the displacement produced by this force is equal to S. It is the shortest distance between A and B, that is equal to the displacement S. And the product of this force and displacement is equal to the work done by the force. So in this case, the work done W is equal to F into S. This is equation 1. So what is the work done by the force on the body in producing a displacement? S is equal to the product of the force and the displacement. Okay. Now from Newton's second law, okay, applying Newton's second law, mathematically the Newton's second law can be written as force is equal to mass into acceleration. Okay, this is the mathematical form of Newton's second law. And once again, here at this point B, the final velocity attained by the body is taken to be V, while the initial velocity at A is equal to 0. So, what should be the acceleration of the body? So, using the third equation, V square is equal to U square plus 2 into A into S. So, V square is equal to 0 plus 2 into A into S. So, from this equation, now, what is the V square equal to? This is 2A S. Therefore, what is acceleration of the body is equal to V square divided by 2S. So, I will number this as equation 2 and the expression for acceleration as equation 3. So, what is the acceleration? A is equal to V square by 2S. So, this equation 3, I am going to substitute equation 3 in equation 2. Therefore, now what will be force is equal to mass into, instead of acceleration, V square by 2S. Therefore, V, that is the F will be now equal to M into V square divided by 2S. Instead of acceleration A, I have substituted V square by 2S. And now you once again look at the equation 1. What is W is equal to F into S. So, therefore now work done, therefore the work done by the force is given by W is equal to F into S, F into S. Okay. So, instead of F, what can I substitute now? M V square by 2S. So, this is equal to M V square by 2S into S. So, which factor is getting cancelled here? S is getting cancelled. Okay, this is now equal to half M V square. M V square by 2 is nothing but half M V square. So, this work done by the force in moving the body from A to B only is stored as its kinetic energy at the point B. So, at point B, the kinetic energy of the body. So, this is the kinetic energy of the body is equal to half M into V square, at which point means at the final point B. So, The kinetic energy of the body is equal to half m into v square. So this is the expression for the kinetic energy of the body. The same also can be derived in a different way also. Suppose you take already the velocity of the body at A is v, and by an opposing force the body is brought to rest. Okay. So in this case, instead of acceleration, retardation we have to substitute. But this will be better choice for you at the 9th standard level. I hope you must have understood. The expression for kinetic energy is what? Ke is equal to half mv square. Examples. So what are all the examples for this? We can give a moving car, we can say. A moving car. Okay. Bullet released. Okay. Bullet released from a gun, or bullet shot from a gun. Okay, shot from a gun. So the bow and the arrow which is released from the bow. So there are so many examples. Have you understood, students? Okay.